Welcome back. In this one we're building a clean and reusable interaction system in Unreal Engine 5. I'll show you a simple setup using line traces and interfaces that you can expand for pickups and anything else you need, all while keeping everything clean and scalable. First we're going to set up our input. Go to your input actions, duplicate your jump action, and rename it to I_interact. Then open up your default input mapping context, add I_interact, and bind it to the E key. Next, we're setting up the interaction interface. In the content browser, right-click, go to Blueprint, and create a blueprint interface. Name it BPI_interact, and then open it up. Rename the default function to interact. Now add an input called interacting actor, and set the type to character object reference. Add a new output called didInteract. Then set its type to Boolean. This will let us confirm whether the interaction was successful or not. Go to your character blueprint and open the event graph. Add your I_interact input. Then from the started pin, drag out and create a line trace by channel. Set the draw debug type to duration so you can clearly see the trace while testing. Drag in your first-person camera reference. Then get its world location and connect it to the start of the line trace so the trace begins from the player's viewpoint. Then get the camera's forward vector, which represents the direction the player is looking, so the trace moves forward in that direction. From the forward vector, multiply it by a float and set the value to around 110 to control how far the trace reaches. Then add this result to the world location and connect that into the end of the line trace. This makes the trace start at the camera and extend forward in the direction the player is looking. From the line trace return value, add a branch to check if the trace actually hit something. If true, take the out hit, use break hit result. And promote the hit actor to a variable so we can store what we've hit. Next, add another branch and check if the hit actor implements the BPI_interact interface. This makes sure we're only interacting with objects that are set up for interaction. Then, take the line trace return value and combine it with the interface check using an and Boolean node. Create a Boolean variable called canInteract. Plug that into the N as well, and use the result to control whether the player is actually allowed to interact. From the true branch, call interact. Set the target to self, and for the interacting actor, get the player character so the interaction knows who triggered it. Create a Boolean variable called isInteracting, and set it to true when the interaction begins. Add a delay of about 1 second. Then set isInteracting back to false to reset it after the interaction finishes. From the false branch, also set isInteracting to false to ensure it doesn't stay active if the interaction fails. Go to your icons folder and open up one of the icon textures. In the Details panel, set the texture group to UI so it's treated as a user interface asset and renders properly on screen. Then set the compression settings to user interface 2D to keep the icon sharp and prevent any unwanted blurring. Repeat the same steps for the other icon as well so everything stays consistent. Go to your Blueprints folder and create a new folder called Interactables. Inside that folder, right-click and create a Blueprint class, then choose Actor. Name it BP_item, and once it's created, open it up so we can start setting it up. Go to Class Settings, then under Implemented Interfaces, add BPI_interact so this blueprint can use the interaction system. Next, open the event graph. Right-click and get player character. Then cast it to BP_character. From the cast, promote the result to a variable and name it character ref so we can easily reference the player character later. Right-click and add an event tick. Then drag from it and add a branch so we can check conditions every frame. From your character ref, get is interacting variable to see if the player is currently trying to interact. From character ref again, get the hit actor, which is the object the player is currently looking at. From hit actor, add an equal node and set the other value to self, so we're checking if the player is actually looking at this specific item. Then combine is interacting and the equals check using an and boolean, and plug that into the branch so both conditions must be true before continuing. Right-click in the event graph and create a custom event called Interacted. Connect this event to the true output of the branch so it only runs when the conditions are met. From Interacted, add a delay and set it to 0.3 seconds to give a small pause before the item is removed. After the delay, add Destroy Actor to remove the item from the world once it has been interacted with. Add a static mesh component to the blueprint. Enable engine content, then set the mesh to cube. Set the X value to 0.15, the Y value to 0.07, and the Z value to 0.04, adjusting them as needed to match your desired size. Next, add a sphere collision and rename it to outer collision. Then set the sphere radius to 150 for the outer interaction range. Inside outer collision, add a billboard component and rename it to outer icon. Set its Z location to 13. Assign the outer icon texture. Then set the size to 0.015. And untick the boxes for both visible and hidden in-game. Duplicate outer collision and rename it to inner collision. then set the sphere radius to 80 for the closer interaction zone. Duplicate the outer icon billboard, rename it to inner icon, and move it into the inner collision. Also change the texture to the inner icon. Select inner collision and add begin overlap and end overlap events so we can detect when the player enters and leaves the interaction range. From the overlap event, add a branch to check if the overlapping actor is the player. Take other actor and use an equal node, then compare it to the player character. This ensures the logic only runs when the player specifically enters or exits the inner collision zone. Get the character ref and then set can interact to true when the player enters the inner collision. This allows interaction only when the player is within range, so the line trace won't register or allow interaction from outside the inner area. Drag in the inner icon component, and use set visibility, then tick new visibility so it shows when the player is in range. Do the same for the outer icon, but leave new visibility unchecked so it hides. Then duplicate this logic for the end overlap, but reverse the values, set the inner icon to hidden and the outer icon to visible. This makes the icons switch correctly when the player leaves the interaction range. Add begin overlap and end overlap events for the outer collision. Copy the same overlap logic you used for the inner collision and paste it into the outer collision begin and end overlap events. Connect everything up exactly the same way first, just matching the execution flow and branches. Once it's all wired correctly, go through and swap the inner icon references for outer icons so the outer collision controls its own visibility instead. Go to the construction script. Drag an inner collision and get set sphere radius. Promote the radius value to a variable called interact range. Then enable instance editable and expose on spawn so it can be adjusted per instance. Do the same for outer collision, get set sphere radius. Then promote it to a variable called detection range, also set to instance editable and expose on spawn. Compile the blueprint, then set the default values. Interact range 80 and detection range 150 so you can easily tweak interaction distances without editing the blueprint logic. drag your BP_item into the level and adjust the detection range and interact range values in the Details panel to whatever feels right, then test it out. When you enter the detection range, an interaction indicator, outer prompt icon, will appear to show that the item is nearby. As you move closer into the interact range, a second inner interact prompt icon will appear, letting the player know they can actually interact with it. Go to the Content drawer, right-click, go to User Interface, and create a widget blueprint. Name it WBP_HUD, then open it. In the Canvas panel, add an image and set its anchor to center. Set the X and Y size to 6, and set the alignment to 0.5 so it stays perfectly centered. Then, in the Appearance settings, change Brush Draw As to Rounded Box, set the corner radius to 5. Set the outline color to black with alpha L1, and adjust the outline width to 0.7. Set the rounding type to fixed radius so the corners stay consistent. Go to your BP_character and open the event graph. Add a sequence node, then from it create a widget, setting the class to WBP_HUD. Promote the return value to a variable called HUD_ref. Then use Add to Viewport so it shows on screen. This sets up and displays your HUD when the game starts, and storing it as a variable lets you access or update it later if needed. And that's your clean and reusable interaction system in Unreal Engine 5. You can build on this for inventory, weapons, or any kind of gameplay system. It's all designed to scale. If this helped, leave a like, and subscribe if you want more clean, scalable UE5 systems like this.